what we need to do now is let's talk about these individually, because it turns out there's actually more than one kind of lunar eclipse, and there's more than one kind of solar eclipse. So let's talk about the types of eclipse, okay? Let's do lunar eclipses first. Let me flip this over. Here we go. So the types of lunar eclipse. Okay. Now on this picture, I'm going to make the sun really big. So there's the sun, okay? Sun. And I'm going to put the Earth right here. And I'm going to ignore the moon for a second. So the reason that there are different kinds of lunar eclipse is that there's actually more than one part to the Earth's shadow, okay? There's more than one part. And to understand that, let me show you a couple things. Let's imagine there's a person floating around right here. Would that person be able, like they were in space above the Earth, would that person be able to see the sun? Would this person be able to see the sun from right here? Yes or no? No. No, they wouldn't. Because there's a big old Earth in the way, right? And so that means that person would be in complete darkness, okay? Complete darkness. So there's basically a big cone of complete darkness behind the Earth. It's shaped like a cone because the Earth is round, so it's basically a round darkness circle that gets smaller as you go away from the Earth, okay? So that part of the shadow is the darkest part of the Earth's shadow, directly behind the Earth. And that part is called the Umbra. So the Umbra is just a fancy term for the darkest part of a shadow, okay? Now, what if that person was right here? Can this person see the sun? Can that person see the sun? Yeah, they can, right? If they look straight over here, they'll see the sun. But here's the important part. Can they see the sun? Can they see the whole sun? No. If they look over here, if they look in this direction, they could see the sun, right? But if they look down here to see the bottom part of the sun, the Earth's in the way of that part of the sun, right? So that means they're going to get some sunlight, but they're not going to get full sunlight. And that means they're going to be in partial darkness, okay? And the same thing would happen if you're floating around down here, right? So imagine an area of partial darkness that actually spreads out as you go away from the Earth. So this part is very dark. And this place is sort of just a little bit dark. And this part is called the Penumbra. And here's something that's really important. So the Penumbra is not as dark as the Umbra. And it's not just above and below. This should be 3D, so it should spin all the way around the Umbra. Like you've got a dark Umbra center with a Penumbra all around it in all directions. It's like the edge of the shadow. What do these names what does Umbra sort of sound like? What everyday item does an Umbra sort of sound like? Somebody said a Pokemon? I'm not talking about that. What everyday item that you probably use all the time sort of sounds like Umbra? Sort of sounds like umbrella. Yeah, it sounds like an umbrella. And that's not a coincidence. They come from the same root word, okay? Here, imagine that the Earth was an umbrella blocking the sunlight. Umbra, that's why it comes from the same word. It's just like an umbrella blocking rain, right? So if you're under an umbrella, the driest place would be directly under the umbrella, just like the darkest place here is directly behind the earth. But if you stood sort of on the edge of your umbrella, you'd get a little bit wet, just not full wet. That's the penumbra. The penumbra is like the place where a little bit got through, okay? Now, here we go. What shape would this shadow be, the shadow of the earth? What shape would it be if we had like a giant sheet of paper and put it right here, like this? What shape would this shadow be? What shape would the umbra be on a sheet of paper right here? What shape would the umbra be? Don't overthink it. It would be a circle, right? That's correct. Because the earth is round, the umbra would be a dark circle on a sheet of paper, okay? It would just be a dark circle. And the penumbra, because the penumbra goes all the way around the umbra, would just be a bigger, less dark circle. So this right here would be what the shadow of the earth looks like. And now, here we go. Here we get to the eclipses. Imagine that the moon was orbiting around the earth like this, kind of 3D in our picture. Sometimes, because the moon's orbit is a little bit tilted, sometimes it'll go through the umbra, sometimes it'll go through the penumbra, and sometimes it'll just miss the shadow entirely. So, depending on what part of the shadow of the earth the moon goes through, we're going to get a different kind of eclipse. Okay, and there's 3 possible types of lunar eclipse. And let's do those right now. So here we go. Here we go. So let's say, here we go, path 1. Let's say that the moon, for path 1, just goes through the penumbra. Just going, like this is the moon going across. And it just goes through the penumbra. Would the moon get completely dark in that situation? No. The moon won't get completely dark if it doesn't go through the umbra. So what is it going to look like in that case? If that happens, if the moon just goes through the penumbra, remember, it's a full moon. It would, somebody said it would look like it's through a gray filter. Yeah, basically. Imagine a full moon that is slightly dimmer than usual, okay? Slightly dimmer. How slight? You probably have seen the moon do this and not realized you saw it. It's possibly happened to you. So this type of lunar eclipse is boring. If you don't have a picture of the moon to compare it to, like a regular full moon, you won't even notice it. So if it does that, the first type of eclipse is called a penumbral lunar eclipse. Penumbral lunar eclipse. So a penumbral lunar eclipse is the boring lunar eclipse. It's a slightly dim full moon. Okay. Now, path number 2. Let's say that the moon just barely touches the umbra. So path number 2, okay, it just barely touches the umbra. And because it just barely touches the umbra, only part of the moon goes in, not the whole thing. In that case, we're going to call it a partial lunar eclipse. Partial lunar eclipse. And the part of the moon that goes in the umbra would go completely dark. And so essentially what that's going to look like, is it's going to look like somebody took a bite out of the moon. It'll look kind of like that. And it kind of, if you don't know what you're looking at, you might think that you're looking at a moon phase, but the shape is not necessarily the same as a moon phase. And also, as the moon goes across the umbra, you would be able to see the bite slowly move across the moon. The bite wouldn't stay in one place. It would move across the moon over the course of about an hour or so, okay? So moon phases don't do that, so that's how you know you're looking at an eclipse. Okay, here we go. What's the last place? What's the last place that the moon could go? What's the very final path? It's right through the umbra, right? So path number 3 goes straight through the umbra. And if it goes straight through the umbra, how much should be dark? How much of the moon should be dark when it's in the umbra? How much? All of it, right? Yeah, all of it should be dark, okay? And that's why we call it a total lunar eclipse. However, okay, have any of you guys ever seen a total lunar eclipse? Yes or no? Have you seen, any of you guys ever seen one? I've seen a couple. Our college actually set up some viewing telescopes for these things. For those of you who have seen a total lunar eclipse, not a solar eclipse, but a total lunar eclipse, does the moon just look black? No, it doesn't. How does that moon look during that total lunar eclipse? I actually have a picture of one from your book. See if I can find it. Yeah, it looks reddish. It looks reddish. So check this out. Here we go. Down here, this is a penumbral lunar eclipse. And you can see here, basically just looks like a full moon. There's not a lot going on right there, right? Not a lot hanging out. This is a partial lunar eclipse, and you can see that bite taken out of the moon. If we were having a total lunar eclipse, that bite would get bigger and bigger and bigger and bigger until it ate the whole moon. But when it ate the whole moon, the moon's going to light up red. This is what the moon looks like when it's in the umbra, okay? This is crazy. It should be completely dark, but it is not. It lights up red. Okay. So what's going on here? This is not the only time we've seen the moon looking red, right? It's not the only time we've seen the moon looking red. We also saw the moon looking red when it was rising and setting. What was causing the moon to look red when it rose and set? What was that concept? Started with an R. What made the moon and the sun look red when they were rising? Refraction. Yes, refraction. Turns out this is also refraction, just more extreme, okay? More extreme. Check this out. Let me get some space. Need some space for this. Actually, you know what? Let me go back to this picture. There we go. I'm going to add something into this picture. Here's the atmosphere of the Earth. There we go. Here's the atmosphere of the Earth. All right. Imagine a beam of sunlight is coming through right here like this. Okay. If the Earth's atmosphere didn't do anything, that beam of light would continue to go over here, and it would probably end up in the penumbra, right? It would probably end up just going through like that, right? And so that means that if the moon was down here in the umbra, that beam of light wouldn't do anything to it, okay? Now, check this out, though. as soon as that light enters the atmosphere, it's going to start to refract, right? It's going to refract. It's going to bend. And that means that some of that light is going to end up bending down so that when it comes out of the atmosphere, it will go into the umbra. The refraction causes that bend there and causes some of it to come into the umbra. But it has to go through a whole ton of air to get to the other side of the Earth. So what color is the only color that's going to get bent into that danger zone, or the forbidden zone right there? What color is the only one that's going to make it all the way through the atmosphere? Red. Because red bends the least on that pathway through the whole atmosphere, all of the colors will be lost but red. So essentially, our atmosphere is stealing some of the red light from the sun and bending it into its own shadow. So that means that the Earth's shadow is actually full of red light. And we don't normally notice that because if you're standing on the Earth, that red light is going up into space. It's not hitting you. But when the moon gets in the way, it catches that red light during the eclipse, and that's why we see the total lunar eclipse looking reddish. Okay, so here we go. Let me bring this over here. So yeah, the reason that the moon looks red during a total lunar eclipse is the sunlight, the red sunlight trickles around our atmosphere and fills up this shadow. Here's the thing though. This part of the moon in a partial lunar eclipse is also in that shadow. So that means this should look red right here. Why can't we see it? Okay? Why can't we see that red color? This right here, let me put it this way. This part of the moon is just as red as this picture up here. Why can't we see it? It's a trick of the eye, okay? Check it out. What else do we see in this picture? We see that part of the moon. This red light looks bright in this picture, but it's not bright, okay? This is actually very dim. And when your eye sees this part of the moon, which is really, really bright, your eyes adjust to that part of the moon and makes it so you can't see the red light that's right here. But as soon as that light completely covers the moon and we get rid of the bright part of the moon, your eyes adjust and can see the red color, okay? So whenever our eyes see a bright light and a dim light, we can't see the dim light because of the bright light. Somebody's typing something, so I'm going to let them pop that out real quick. Okay. Yes, that's true. Our eyes and our brain, they're just barely hanging on in there. It's all chaos inside of your head. We just hope it makes sense. Okay? Now, here we go. That's the types of lunar eclipse. Let's talk about the types of solar eclipse. Okay?